Hello and good evening. Today I'm going to be describing my concept map of Chapter 1 Vocabulary Chemistry. Now first I just wanted to give a good look of the overall organization. As you can see, the top and the bottom have a whole lot more going on than the right and the left. So I'm going to start at the less clustered spots and let's get to it. So, the chemistry vocabulary. We're going to start off with something that it includes, which is polymers, such as carbohydrates, glycoproteins, unsaturated fats, saturated fats, and glycerol. And another polymer that constitutes a lot more than in this concept map are sugars. And sugars can be made from monosaccharides or polysaccharides, and polysaccharides are also made from monosaccharides. So you see there's a lot more going on with the sugars section. And back to polymers, there's another example on here as well. That example is lipids. And lipids can form glycolipids, phospholipids, and they are also made of fatty acids. Now, of course, there's a lot more to all of these polymers, but as far as what constitutes the total of the vocabulary here, that's it. Now, the next section of Chapter 1 of the chemistry vocabulary includes many reactions. And the one that is covered in this section is the redox reaction. Now, redox reactions involve an acid and a base, almost always, as far as I know. Now, an acid is the electron acceptor. The base is the electron donor. And both an acid and a base combine to form, or we'll start with what they're measured by, which is pH. And now when you put an acid and a base together in a reaction, as far as I've ever seen, they always combine and form a salt, which is the ionic bonded byproduct from those reactions. Next section of the chemistry vocabulary includes SI units of measurement, such as a gram, which is a unit of weight, a meter, unit of distance, a liter, unit of volume, which is often measured in the form of a milliliter, because in the lab most of the time you're looking at microscale stuff, and for this reason 90% of the time you're using milliliters, not liters. Alright, now for one of the big topics of chemistry in this section. It includes elements. I mean, what's more basic with chemistry than the elements? Now, elements can have a radioactive isotope, for example, like uranium. They can have an isomer like carbon. You've got the carbon-12 or carbon-13. They also all have a half-life, but all of their half-lives are different as far as I know. And this is the amount of time which half of it will decay. They've all got their atomic number, constituting the amount of protons. They can be measured through electronegativity, with fluorine being the most electronegative element, and I believe it's francium down at the other end of the spectrum. And elements are made up of atoms. Now, atoms contain neutrons, protons, and electrons, the three main basis makeup of atoms. Now, the protons and the neutrons make up the nucleus, and when you have extra protons in an atom, that's going to lead you to a cation. And the electrons, the opposite of protons, they're going to create an anion when you have extra electrons, or more electrons than protons would be a better way of describing that. And electrons are going to be found in the electron shell. And in those electron shells, there's a valence shell, which is the outermost shell. And back down to elements. So elements, for example, They're involved in organic and inorganic chemistry. I mean, no matter which way you turn, you've always got elements. Organic chemistry tends to focus on carbon, though. And, again, for example, there are the NOCH elements, those that are considered those most important to life, which are nitrogen, oxygen, carbon, and hydrogen. And other important elements include sulfur, calcium, sodium, potassium, chlorine, and phosphorus. And finally, in the elements category, they're all going to have an atomic weight, which is derived from the molecular weight. And the atomic weight is based on a mole, which is used to measure molarity, moles over liters. And the moles are determined by Avogadro's number, the amount of atoms in an element, or in a carbon-12 element that provides the basis for the rest of those to be measured. Now back over here to molecular weight, and a measurement often used is the Dalton. Alright, now the last section of this concept map for chemistry. Chemistry includes functional groups like sulfhydryl or methyl, alcohols, aldehydes, ketones, carboxylic acids, and carboxylic acid, ketones, and aldehydes are carbonyls, which is a carbon double bonded to an oxygen. The carboxylic acids can be simplified when naming to and be called carboxyl. Now back up. Functional groups, and you've also got amines and aminos, which can form amino acids that make up proteins. And functional groups like phosphates, which make up DNA strands coupled with nucleotides that combine to form nucleic acids. And then also, another functional group is hydroxyl, which can form a hydronium ion or a hydrogen ion. Hydronium is H3O plus, and the hydrogen ion is H plus. And the final branch coming off of functional groups is that they are held together by different types of bonds. And these bonds can create cohesion or adhesion, and some different type of bonds like an ionic bond or hydrogen bonds. And an example of some hydrogen bonds are like what is found in water, H2O. And these hydrogen bonds illustrate, water. Hydrogen bonds are found in water and the water isotopes. And water illustrates hydrogen bonding in water, obviously. And the hydrogen bonding in water is that big system of connected bonds and elements of H2O that create the big bodies of water, or puddles even, that we see every day. Back up to the different types of bonds. The last one covered are covalent bonds. Now these covalent bonds can be polar covalent. They can be single covalent bonds, double covalent bonds, or triple covalent bonds. And they can also be nonpolar covalent bonds that undergo hydrophobic interactions, because water is a very polar substance, and like dissolves like, so when you've got a nonpolar covalent bond, it's going to be hydrophobic. It's going to push away all the water. Alright. I believe that about covers that entire concept map. And I hope it was clear to see in the video. If you have any questions, just email me. Thanks.